Have you ever gazed up at the night sky and wondered if we're alone in this vast universe? This innocent curiosity has been a part of the human psyche for as long as we've been able to look up and see the stars. It's a question that has inspired countless tales of science fiction. But it's also a very real scientific question, one that researchers around the globe are dedicating their lives to answering. Throughout history, our understanding of the universe has evolved dramatically. From believing we were the center of it all, to realizing we are but a tiny speck in the grand scheme of things, our perspective has shifted, and with it, so has the possibility of life beyond Earth. In our quest to answer this question, we've developed theories and equations to help guide us. One such theory, the Fermi paradox, named after physicist Enrico Fermi, postulates the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. It's a paradox that continues to baffle scientists and stoke our collective curiosity. Then there's the Drake equation, developed by astronomer Frank Drake, not to quantify the number of civilizations, but to stimulate scientific dialogue on this cosmic conundrum. It's a fascinating equation, factoring in variables like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. It's a tool that gives us a framework to hypothesize the potential for extraterrestrial life. These theories, these equations, they all stem from our innate curiosity, our need to know what's out there, our longing to not be alone in the universe. But they are also a testament to our scientific progress and our relentless pursuit of knowledge. So, let us embark on this cosmic journey, exploring the intriguing possibilities of life beyond our blue planet. As we delve into the mystery of the universe, remember, it's not just about finding answers, but about asking the right questions. And the question of life beyond Earth is perhaps the most profound of them all. Our journey begins with the hunt for planets beyond our solar system, known as extrasolar planets or exoplanets. The vast cosmic ocean is teeming with these celestial bodies, orbiting stars light years away from our home planet. The question then arises, how do scientists detect these distant worlds? The answer lies in two ingenious methods, the transit method and radial velocity. Picture this. You're gazing at a star and suddenly, its light dims slightly. This tiny dip in brightness, registered by high-tech telescopes, signals the transit of a planet in front of the star. This is the essence of the transit method. On the other hand, the radial velocity method involves observing the slight wobble of a star, caused by the gravitational tug of an orbiting planet. The change in the star's speed, as seen from Earth, can tell us about the mass and orbit of the planet. These methods have opened up new worlds, literally, for us to explore. One of the most intriguing exoplanets discovered so far is Proxima Centauri b. It's the closest known exoplanet to us, orbiting the star Proxima Centauri. This planet lies in the habitable zone, where conditions might just be right for liquid water to exist, and where there's water, there could be life. Another fascinating world is TRAPPIST-1e, a part of a unique system of 7 planets orbiting a single star. This planet too lies within the habitable zone and is close in size to Earth, making it a potential candidate for hosting life. These distant worlds, so different from our own, offer tantalizing clues in our quest for extraterrestrial life. Exoplanets, in their variety and abundance, remind us of the limitless possibilities the universe holds. As we continue to scan the skies for these alien worlds, we're not just searching for new planets, we're searching for answers to some of the most profound questions of our existence. To understand where life might exist, we need to understand the conditions life needs to thrive. Imagine a cosmic kitchen. The chef, a whimsical force of nature, is about to whip up a batch of life. What ingredients would they need? What is the recipe for life as we know it? The answers lie in the concept of the habitable zone, or as it's more charmingly known, the Goldilocks zone. The Goldilocks zone is that sweet spot in a solar system, not too close but not too far from the star, where conditions are just right, just like the porridge in the tale of Goldilocks. It's in this zone that a planet could have liquid water, a key ingredient in our recipe. Water is the universal solvent, the medium in which all the biochemical magic happens. But our cosmic chef knows that water alone isn't enough. A stable climate is also crucial. You see, too much change, too quickly, and life might not have the chance to adapt and survive. A planet needs a stable orbit, a gentle tilt, perhaps even a moon to stabilize it. Next, our chef adds a dash of the right chemical elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 elements, known as schnapps, are the building blocks of all life on Earth. They form the proteins, the DNA, the carbohydrates, essentially everything in an organism's body. But what if our cosmic chef decides to experiment? Could life exist with a different recipe? Silicon-based instead of carbon, or ammonia instead of water? The possibilities are fascinating and endless. Knowing what life needs helps us narrow down our search, but the universe may still surprise us. You see, the universe is a master chef, always ready to surprise us with its creations. It's our job to keep exploring, keep sampling, and keep our minds open to the endless possibilities. After all, the universe has been cooking up wonders for billions of years. Who knows what other incredible recipes it might have up its cosmic sleeve? While we search for planets that might harbor life, we also listen for signals that might reveal intelligent alien civilizations. In our quest to answer the age-old question, are we alone in the universe? One of the most intriguing pursuits is the search for extraterrestrial intelligence, or SETI. This scientific endeavor seeks to detect signals from advanced civilizations elsewhere in the cosmos. The primary tool in this quest is the radio telescope, a mighty instrument that scans the skies, listening for transmissions that might indicate the presence of intelligent life. These telescopes are gigantic, with dishes spanning hundreds of meters in diameter, and they listen to a wide range of frequencies, much like tuning a radio to different stations. One of the most fascinating episodes in the history of SETI is the story of the WOW signal. In 1977, a radio telescope at Ohio State University picked up a strong 30-second burst of radio waves from the direction of the constellation Sagittarius. The signal was so impressive that the astronomer who discovered it wrote "WOW" next to the data printout, hence the name. The WOW signal was exactly what SETI researchers were looking for: a strong, narrow-band signal, not known to be produced by any natural celestial source. However, despite decades of searching, the signal has never been detected again. This has led to much debate among scientists. Some suggest it might have been a transmission from an alien civilization, while others propose more mundane explanations, like a passing comet or a terrestrial radio interference. No matter the truth behind the WOW signal, it serves as a reminder of the tantalizing possibilities that await us in the search for extraterrestrial intelligence. Every day, our radio telescopes continue to scan the skies, listening for a sign that we are not alone in the universe. The silence of the cosmos is a mystery, but perhaps it is only a matter of time before we hear a whisper from the stars. As we continue our cosmic journey, the possibilities are endless. Indeed, our quest to understand the universe is not only driven by an insatiable curiosity, but also by the tantalizing prospect of discovering life beyond our home planet. In the near future, we can look forward to several groundbreaking space missions that could potentially revolutionize our search for extraterrestrial life. One such mission is the launch of the James Webb Space Telescope, an instrument so powerful that it will allow us to peer back to the early universe. With its advanced infrared capabilities, it will be able to detect the faintest glimmers of light from the most distant galaxies and perhaps even signs of life on exoplanets. Then there's the Breakthrough Listen project, a massive scientific research program aimed at finding evidence of civilizations beyond Earth. Using the most sophisticated technologies, It will scan the million closest stars to Earth, the center of our galaxy, and the entire plane of the Milky Way. The potential impact of finding alien life cannot be overstated. It would fundamentally shift our perspective on our place in the universe. No longer would we be a solitary species on a lonely planet in the vast cosmic sea. Instead, we would become part of a larger cosmic community, connected by the shared experience of life itself. Furthermore, the discovery of extraterrestrial life would provide a mirror through which we can see ourselves. It would force us to question what it means to be human, to be a life form, to be a part of this grand cosmic dance. It might even challenge our notions of life and intelligence, pushing us to broaden our definitions and our understanding. In the end, whether we are alone or not, our journey through the cosmos is a testament to our curiosity and our desire to understand the universe we call home. Our cosmic journey, filled with wonder and discovery, is a testament to our resilience as a species and our relentless pursuit of knowledge. It's a journey that, regardless of what we find, will continue to inspire us, challenge us, and shape us for generations to come.